Hello, and welcome to the Science for Sleepy. Tonight, the lab is quiet. Only the soft rustle of pages and the low hum of something ancient fills the space. On the desk, a candle flickers beside a cup of cooling tea, casting golden light across charts, photographs of galaxies, and sketches too faint to finish. The sleepy scientist doesn't stir, their breath slow and deep. A pen rests loosely in one hand. On the page beneath it, a circle drawn in silver ink, spiraling gently inward. If you're enjoying this quiet journey through curiosity and time, consider subscribing. There's always more to explore, gently. We'd love to know your location and time zone in the comments. Outside the observatory dome, the sky stretches wide, black, silent, untouched. It is a canvas of stars, and yet tonight we are drawn to the darkness between them. That darkness is not emptiness, it is memory. And before the galaxies were born, before the stars ignited, there was only this, a whisper in the void. No colour, no matter, no light, only a field of quantum possibility, a trembling at the base of everything, like ripples waiting beneath the surface of a still pond. The universe was not yet shaped, but it was stirring. We drift now beyond time into that pre-moment. The first breath has not been taken. The first spark has not lit. Yet within this hush, the seed of every galaxy is held. You might imagine it as a silence so total that it hums, not because there's sound, but because even silence has structure, and in that structure, fluctuation, quantum foam they call it, particles appearing and disappearing, existing for fractions of a fraction, then gone again. But in those flickers, slight imperfections formed, not chaos, not disorder, just enough variation to begin shaping fate, because not every part of the early universe was perfectly uniform. There were tiny, denser places where matter would, in time, gather. That gathering would become gravity, that gravity would become collapse, and that collapse would become the galaxies we see today. But right now, none of that has happened. We're still floating in the in-between. The sleepy scientist stirs, murmuring something soft, perhaps a formula from a dream, perhaps just breath. Back in the void, time begins to unroll. Like a thread of silk pulled slowly through a loom, the first second, then the second after, and with them the universe begins to expand, not into space, but as space. The vacuum stretches, light will come later, matter will come later. But for now, we're inside the echo of the first shift, the inflationary moment, a fraction of a second where everything expands faster than we can imagine, smoothing, flattening, but leaving behind those subtle ripples. These ripples are the blueprint. They are the map. They will decide where galaxies will form. They will shape the scaffolding on which stars will hang. But for now, they are only suggestions. Gentle, mathematical promises whispered in the fabric of space. You begin to understand. The galaxies did not appear out of nowhere. They are the consequences of an ancient pattern, one woven into the cosmos before the cosmos even knew itself. You breathe slowly, deeply. In this darkness, there is no need for fear, only stillness, only waiting. Because soon the light will arrive. But for now, we listen to the hum beneath the silence, and we wait with the cosmos. It begins not with a bang, but with a glow. Out of the darkness, after the inflation, after the first fractions of time unfolded like silk over a sleeping world, the universe cools just enough to release the light. Not blinding, not sharp, just the first breath of radiance. Soft, newborn photons loosed from matter for the very first time. This is recombination. Until this moment, light has been trapped. Photons constantly collided with charged particles in a dense plasma, unable to travel far before being scattered and swallowed. The universe was opaque, murky, glowing, but blind. And then, it clears. Electrons find protons, hydrogen atoms form, the fog lifts. For the first time, light is free. This light, ancient, soft and endless, will travel through the cosmos forever. We still see it now. We call it the cosmic microwave background, a whisper from the beginning, still touching us today, 13.8 billion years later. You float in that moment now. It is not sudden. It is not loud. It is a hush lifting from a deep lake. The photons begin their journey, and though they are everywhere, they are not yet organized. They do not yet know what they will illuminate. But their release marks a boundary, the end of one era, the beginning of another. We drift now through that early universe. The heat is falling. Everything is expanding, slowly, softly. And in the distance, still far from forming anything we'd call a galaxy, clouds of hydrogen begin to gather. They are enormous, stretching across unimaginable scales, and yet they are quiet, cold, waiting for the smallest imbalance to become collapse. You see them forming, dense knots within the expanding fog, like breaths drawing inward, the seeds of stars, the hints of clusters. But nothing has ignited yet. The sleepy scientist dreams of this moment often. There is a sketch pinned above their couch, hand-drawn circles with arrows spiraling inward. Beside it, a single line in pencil. Before light made shape, it made memory. You understand now. The photons, though light, do not build. They reveal. And what they will reveal, what they will touch and scatter through, is only just beginning to take form. We are drifting in the era known as the cosmic dark ages. There are no stars yet, no galaxies, just the vast silence of hydrogen and the slow curling fingers of gravity beginning their pull. But already, the map is set. The tiny ripples from inflation, the denser and thinner patches of space, have determined where matter will pool. We follow one such region now, a little more dense than its neighbours, not enough to notice unless you had infinite patience. But gravity notices. It begins to pull, to tug, to whisper, come closer, and the hydrogen obeys. There is no rush. The first galaxies are still hundreds of millions of years away, but their outlines are drawn, and we are there, in the spaces between, drifting beside that first breath of light, watching as the fog clears and possibility widens. This is not the birth of a galaxy. It is the breath before the birth, and it matters just as much. You close your eyes, sensing the balance between expansion and collapse, between freedom and form, between silence and the first stars yet to come. The light has been freed, and what it will one day shine upon has begun to take shape. Now we drift deeper into the dark. The light has been freed, yes, but stars have not yet awakened. Around us, hydrogen and helium floating quietly through an ever-expanding universe. These elements are not burning, not yet. They are cold, invisible mist, filling vast gulfs of space with potential. You might imagine it like this: an endless ocean, clear and calm, with no wind to stir its surface. But beneath, something is gathering. These gases do not remain perfectly still. Even in silence, the universe breathes. Tiny variations in density begin to ripple. A little more matter here, a little less there. Imperfections from the earliest quantum tremors are now maps for gravity's hands to follow. We begin to see structure, not form, not shapes yet, but the suggestion of it. Long strands like invisible threads where hydrogen accumulates. These will become filaments, highways, the future paths of galaxies. Between them lie vast voids, spaces destined to remain mostly empty, where gravity's grip was just a little too soft. But in these strands, in these hidden rivers of gas, the earliest collapses begin, gently, patiently. Over hundreds of millions of years, clouds fall inward on themselves. Slowly, under their own weight, the gas compresses. There is no flame yet, no brightness, but pressure is building. We follow one such cloud now. It is enormous, light years across, but delicate. The gas inside is thin, diffuse, vulnerable to disruption, and yet gravity continues to gather it, shaping it, squeezing it inward. It is in these cold cradles that the first stars will form, and in forming, they will light the way for galaxies to be born, but not yet. Tonight, we hover just above the threshold. Imagine drifting inside one of these proto-clouds. There is no sound, no colour, just shifting temperature, motion, pressure. At the centre, gas becomes denser, heavier. It begins to heat, not by fire, but by friction. Motion converting to warmth. Molecules pressed so close, they resist. You breathe slowly. The sleepy scientist has drawn something like this on the window glass of the observatory. A spiral within a spiral, coiled inwards, becoming darker at its centre. This is how galaxies will form, not as explosions, but as soft concentrations of cold matter pulled close. Before stars are born, the darkness must first deepen. There's something poetic in that. In this early universe, darkness isn't the absence of light, it's the preparation for it. The quiet gathering before the choir. The slow breath in before the first note. You linger here. We have not yet seen a galaxy. We have not yet seen a star. But the materials are here. Dust in the dawn, hydrogen, helium, cold and patient, and gravity, always gravity, pulling softly at every particle, asking them to come together, asking them to become something more. It is not a command. It is a suggestion, a leaning, a gentle curve in the fabric of space. And because of that curve, the clouds fall. And because they fall, heat rises. And because heat rises, light will come. But for now, we drift between the gathering shadows, and we listen to the weightless murmur of gas on the edge of transformation. Nothing has burned yet, but the match is in motion. We're still inside the hush. But now we begin to feel the pull more clearly, the quiet fall of gravity. There is no crash, no tearing, no thunder, only a deep, persistent curling inward. Across vast stretches of gas and time, hydrogen clouds are slowly surrendering to their own weight. They do not fall like leaves, they collapse like sighs. Gravity is not loud in these early ages. It doesn't need to be. It is written into the structure of space itself, and space, having expanded so dramatically at the dawn, is now gently allowing these clouds to condense. You might imagine a ball rolling downhill, but here the hill is made of curved space. The ball is made of gas, and the journey is so slow that it takes millions of years to notice the descent. Yet it happens, and once it begins, gravity never lets go. One cloud folds inward, then another. Small clumps inside them form denser knots, regions where collapse intensifies. Like raindrops forming in a thunderhead, these knots become the sites of something new. A star is preparing to be born. We watch from within, drifting closer to one such clump. The heat is rising. Atoms are jostling more violently now. Pressure builds not suddenly but steadily. The collapse tightens. The center grows hotter, brighter, not bright to the eye, yet, but to the touch of radiation. Eventually the moment comes. Hydrogen nuclei smash together, Fusion begins, a star is lit, and just like that, the first point of light appears in the cosmic dark. Not alone, others will follow, but this is among the first, a brilliant beacon in a sea of shadow. The sleepy scientist dreams of this moment often. On the desk, a candle has long since gone out, but beside it lies a page filled with tiny stars, penciled dots swirling across the paper, some brighter than others, each circled in light graphite rings. This is where the structure begins, with gravity's quiet suggestion, with gas that folds instead of resists, with the ignition of fusion in the heart of what was once a cloud. But the story is bigger than any single star. Because these stars, these first beacons, are not isolated. They form in groups, clusters within the clouds, like embers in the same breath, and around them, more gas continues to fall inward, pulled not just by gravity now, but by the stars themselves. Their light ionizes nearby hydrogen, changing the chemistry of their cradles. Their winds push and shape the remaining gas, guiding where the next collapse will occur. Some stars explode, not in anger, but in inevitability. The most massive among them burn fast and die young. Their deaths scatter heavier elements into space, enriching the surroundings with the materials that will build planets and eventually us. This cycle continues: collapse, ignition, death, rebirth. And around it all the structure begins to spiral. What was once a cloud becomes a cluster. What was once a cluster becomes a galaxy. Not in a single leap, but in countless steps. Not in chaos, but in slow, ordered grace. We float back now, watching the pieces gather. Gravity has done its part. It pulled the gas, it lit the stars. Now it shapes the galaxy. Edges blur, rotation begins. The cloud doesn't just fall inward, it spins, flattening into a disk. Angular momentum preserved across eons becomes structure. What began as formless cloud is now a swirling system, not neat, not clean, but definite. The first galaxies are forming. You exhale slowly. The sleepy physicist's chalkboard glows softly in the dark. Simple spirals sketched among formulas, a gentle echo of what we've just seen. It began with the fall, not a fall from grace, but a fall toward structure, a fall toward light and gravity. Quiet, tireless, eternal, was the one who pulled it all into place. They are forming now, galaxies, not as we know them in today's skies, not yet, but the first of their kind. Strange, uneven, radiant in places, collapsed in others. They are messy, tumultuous, beautiful in their chaos. We drift among them gently, letting our senses absorb the textures. Some look like jagged clouds stitched with flickers of starlight. Others have begun to swirl like puddles disturbed by distant echoes. All are young, hot, and wild. These are the first galaxies, small compared to the giants we see today, but glowing with the fierce light of countless newborn stars. Some are only a few thousand light-years wide. Their shapes are undefined, unstable, but they shine. Starlight is new to this cosmos. Galactic light even more so. Imagine seeing the universe open its eyes for the first time. That's where we are now. These galaxies burn with stars that formed quickly, lived briefly, and died violently. Supernovae explode like cosmic punctuation marks, flinging enriched material into space, seeding the next generation. It is not peaceful, but it is purposeful. The sleepy scientist rolls slightly on the couch, hand brushing a nearby notebook. On its open page, chaotic swirls, dark smudges, and little golden circles, scattered like a star map redrawn from memory. This is the moment when galaxies stop being theory and start becoming architecture. But they are still growing, still uncertain. Their shapes are temporary, their masses unstable. They tug at nearby clouds, draw in satellite clusters, and merge with other infant galaxies. The process is not smooth. We see two small galaxies collide now, slowly, majestically, like dancers meeting in a slow-motion storm. Their stars mostly pass through each other, but their gas collides, compresses, ignites. A burst of new stars erupts where the chaos is greatest. Galaxies do not grow in isolation, they feed on one another. The collisions can last billions of years, their effects visible even longer. You begin to sense a pattern emerging beneath the disarray. Despite the turmoil, gravity is orchestrating something coherent. Structures stretch outward. Gas flows along filaments. Larger galaxies swallow smaller ones. And from that process of combination and collapse, the familiar spiral begins to whisper into shape. But not all galaxies become spirals. Some remain irregular, tossed and tattered by gravitational tides. Some will become elliptical, rounded, smooth, old even when young, built by the violent merging of others. Each one is shaped not by a single rule, but by countless accidents and influences. Environment, collision, rotation, pressure, density. We move now through a field of these fledgling galaxies, each one glowing with youthful heat, some breaking apart, others doubling in mass within a moment of cosmic time. The sky is crowded, busier than it will ever be again. There is something tender about this epoch, like watching children grow up too fast, pulled into the responsibilities of structure before they have time to rest. But this is how the universe builds, in fire, in union, in rhythm. The sleepy scientist's chalkboard holds a single phrase in chalk, faint beneath the scribbled spirals. What begins in chaos tends toward form. We stay a little longer in this crowded sky. You let your thoughts dissolve into motion, into dust, into light. Galaxies are blooming, not with order, yet, but with intent. They do not know what they will become, but they are becoming. You drift onward, the hum of stars growing more steady now. Behind us, the darkness fades. Ahead, the shape of the cosmos begins to take hold. We begin to see it now. Not just stars, not just galaxies, but structure. The universe is not scattered randomly. It is webbed, threaded, organized in a pattern so vast, so intricate, it takes billions of years to truly emerge. We drift through what is called the cosmic web. Long, luminous filaments of dark matter and gas stretch across the universe, linking galaxies together like veins through a living body. Between these threads lie enormous voids, quiet expanses where almost nothing has formed. This is not chaos, this is architecture. And the architect? Something invisible, something silent, dark matter. You can't see it, you can't touch it, but its presence is everywhere, like scaffolding wrapped in fog. Dark matter does not shine, it does not burn, but it pulls, gently, persistently, shaping the structure of everything else. Galaxies do not form in empty space, they form along these threads, gathering like dew on a spider's web. The filaments are not static, they guide the flow of matter, the dance of gravity, the swirling of gas into stars. We move along one such thread now. It stretches for millions of light years, and galaxies sparkle along its length like beads on a string. Each one has a story, each one formed in response to gravity's call, dark matter's pull, and gases' slow collapse. The sleepy scientist has drawn something similar in their notebook. A black line curls across the page like a vine, with dots clustered tightly at intervals. Beside it, in small script, We grow along what we cannot see. You wonder what it must be like to be shaped by something that never reveals itself. And then you realize we all are, in some way. Dark matter doesn't just organize space, it defines possibility. Galaxies form where it is dense, they cluster where its pull converges, and in the deepest wells of dark matter, the largest structures in the universe are born. We arrive now at one such place, a node where filaments intersect. A galactic cluster is forming here. Hundreds, even thousands of galaxies are falling toward each other, drawn by dark matter halos and mutual gravity. The collisions are slow, quiet, inevitable. And in their convergence, something greater is made. The gas between these galaxies is heated to extraordinary temperatures, so hot it glows in X-rays. It is not empty between galaxies, it is alive, pressurized, listening. The universe is building not just stars, not just galaxies, but communities. Superclusters stretch across unimaginable expanses, filaments crossing filaments, galaxies drifting in synchronized orbits. The web is alive, and we are floating through it. Yet, for all its grandeur, it is still growing. Dark matter continues to guide the flow. Gas continues to fall along its paths, and galaxies continue to form at its densest intersections. You understand now, galaxies are not isolated, they are part of a larger rhythm, a choreography invisible to the eye but unmistakable to the cosmos. We drift back now from this tapestry of structure. The web becomes mist, the filaments dissolve into shadow, but we remember the shape. In the lab, the sleepy scientist's candle has gone out, but its afterglow reflects in a curved glass dome above, a mirrored sky, a quiet echo. Everything we have seen tonight began in silence, but it did not stay there. Structure grew from stillness, form rose from the fall, and across it all, dark matter played its invisible song. They shimmer now, these early galaxies, more vivid, more complete. Not yet like the grand spirals etched into modern telescopes, not yet the ellipticals we associate with age and stillness. But something is changing. They are beginning to settle. We drift closer to one. It is still young, still raw, but you can feel the rhythm beginning to emerge. Stars orbit around a growing center, gas coils inward, dust spins outward. It is not yet symmetric, but it is striving to be. This is the moment when galaxies first sparkle. Their stars are no longer just the massive, short-lived kind. Now, cooler, longer-lived stars begin to appear, red dwarfs, yellow suns. They burn steadily, quietly. They will last billions of years. They give a galaxy its persistent light. As more stars are born, the galaxy glows more evenly. Its center grows dense. Its arms, if it has them, begin to unfurl. This is where form becomes elegance, where chaos gives way to identity. You begin to sense the distinction between one galaxy and the next. Some begin to take on a spiral structure, broad and curling, like waves frozen in space. Others are irregular, starlight scattered like ashes on the wind. Some drift toward becoming compact spheroids, future ellipticals in the making. There is no uniform path. Each galaxy is its own experiment. We pass through a region where several young galaxies cluster together. Their halos overlap. Their motions influence each other. Some are being torn apart. Others are pulling companions into slow spirals, building mass and motion with every encounter. A small galaxy merges with a larger one, a quiet event from our perspective, but a cataclysm for the stars inside. Gas is compressed, and a burst of star formation lights up the darkness. Blue giants flare into existence, Supernovae crackle like fireflies in a storm. The sleepy scientist murmurs in their sleep. Their notebook lies open on the floor, covered in little spirals and one short line. A galaxy becomes itself through others. We understand. No galaxy is shaped alone. Each one carries the marks of its neighbours, of its collisions, of the matter it gathered and the dust it left behind. Each one is a story told in gravity and light, and now their stories are being written more clearly. We visit a spiral galaxy just beginning to stabilise. Its disk is thin, wide, rippling with the birth of stars. You might imagine it as a cosmic vinyl record, each groove a timeline of starlight, each arm a melody stretching toward the future. The galaxy rotates, not like a wheel, but like a dance. The outer arms move nearly as quickly as the centre. A puzzle that puzzled us for decades. A sign that dark matter holds everything together from the shadows. But even if we didn't know why, we would still know beauty when we saw it. These early spirals shimmer with blue light, the signature of new, hot stars. They are young and luminous. They make the universe feel alive. We drift on past dozens more. Some spin, some wobble, some glow like lanterns in a dark cathedral. All of them are finding their shape, their rhythm, their light. You wonder, when did the universe stop being only potential and become a place? Perhaps here, perhaps now, when the galaxies first sparkled, when structure became story, when the darkness found its voice through starlight, and even now, their voices echo. We move now into quiet collisions, not the dramatic smash of two cars or the clamour of crashing metal. These are cosmic mergers, slower than memory, broader than imagination. Galaxies meeting galaxies in the most graceful kind of chaos. We watch from afar as two galaxies, one larger, one smaller, begin to drift together. Over millions of years, their outer halos touch first, like tides brushing against each other across a bay. The stars inside do not collide. Space is too vast, but the gas does. And when gas meets gas, it compresses. Compression means pressure. Pressure means ignition. Stars flare to life in sheets, in waves, in bursts. Blue, young, luminous stars. The galaxy lights up like a campfire stoked from both sides. This is a starburst galaxy, where mergers make stars faster than any calm spiral ever could. You drift through the heart of the merger. The light is thick here, and the motion dizzying. Stars orbit one another in elongated loops. Clouds of dust spiral inward. Cores stretch and distort. Eventually, over the course of cosmic time, the two become one. The new galaxy may look nothing like either of its parents. Its shape might be round, irregular, twisted, or completely smooth. This is one way elliptical galaxies are born, not by slow formation, but by the forceful blending of spirals. The sleepy scientist has scrawled a single phrase at the edge of a chart pinned to the wall. Violence is part of beauty. Not violent in intent, just in scale. These mergers are not destruction, they are transformation. We hover now near a larger cluster, where many galaxies are bound together by gravity. Mergers happen often here. Some are fast and disruptive, others are slow, tidal, stretched out across billions of years. The cluster's core is a massive elliptical galaxy, round, faintly glowing, old. Its stars are reddish, cool. It has not made many new stars in a long time. This is the result of too much merger, too much motion, too much heat. In these environments, galaxies often burn through their gas and settle into quiet. Star formation slows. The light dims, not into darkness, but into maturity. You sense the mood shift here. The universe is still building, still growing. But its first youthful brilliance is beginning to pass. The wild fireworks of early formation give way to more measured rhythms. Galaxies learn their pace. Some spiral on in grace, others rest as glowing embers in massive clusters. And yet, even in maturity, there is change. Galaxies may still consume smaller ones, swallowing them whole. These minor mergers, called galactic cannibalism, reshape the edges, extend the arms, thicken the core. You see streams of stars wrapping around host galaxies, remnants of those that wandered too close. In a way, every galaxy carries the history of its meals, like fossils in orbit, and you begin to see the truth in the chalkboard sketch left by the sleepy scientist. A spiral, being eaten slowly by a larger halo. Below it, in soft graphite, nothing is lost, only folded in. We pause now, surrounded by a dozen galaxies in different stages of merger. Some are just beginning to reach toward each other. Others are mid-collision, twisting, glowing, roaring in silence, and some are the quiet aftermath. The cosmos does not avoid collision, it embraces it, because every collision brings new shape, new light, new memory. We drift onward. The stars are dimmer here, but they are wiser too. Now we drift into the deep time of the cosmos. The fireworks of early formation have faded behind us. The mergers have slowed. The brightest blue stars have long since burned out. What remains are the survivors, the older stars, steady and slow burning, lighting the paths through spiral arms and galactic cores with a softer glow. Galaxies now have matured. We pass through a spiral galaxy stretched wide across space. Its arms are finely shaped, wrapped in ribbons of dust and starlight. It has settled into grace, rotation not frantic but measured. Stars orbit the center like dancers around a hidden music, and at the center, a quiet hunger. Here lies one of the most mysterious actors in our story, the supermassive black hole. Every large galaxy has one. Millions, sometimes billions of times the mass of our sun, compressed into a single invisible point. We cannot see it, but we see what it does. Stars orbit faster near the core. Gas spirals inward, heating as it falls, lighting up in X-rays and ultraviolet before vanishing beyond the event horizon. This is not the violence of youth. It is the precision of age. You might expect a black hole to devour everything around it, but galaxies endure. These central voids don't destroy the galaxies they inhabit. In many cases, they help shape them. The sleepy scientist has a diagram on the floor beside their pillow, a spiral galaxy drawn in chalk, its center marked with a deep black dot. Below it, in soft handwriting, the quietest force is often the most patient. We watch as matter swirls into a supermassive black hole. It does not fall directly. It circles, flattens into an accretion disk, glows fiercely, then vanishes. And when enough gas is falling in, the black hole awakens. It becomes a quasar, a brilliant, radiant engine of light and power, outshining the entire galaxy around it. We see one now. From this distance, it looks like a star, but brighter than any star has ever been. Its light pulses across space, a lighthouse beam from the early universe. Quasars are brief. They flare, they feed, and then they fade. Their galaxies settle down again, often quieter than before. Some quasars are ancient memories now, their light just arriving after travelling for billions of years. You may be the first to receive it, a soft beam from a past that no longer exists, and yet it speaks. These moments help define the lifespan of a galaxy. Galaxies have histories. They're not eternal in form. Some transform completely over time. Spirals can become ellipticals. Star-making factories can fall into silence. gas can run dry, and in the absence of new stars, galaxies age. We pass now through a galaxy filled with red stars. No new stars are forming. The gas is gone, either consumed or blown away long ago. This galaxy is quiescent, not dead, but quiet. It glows faintly, like a fading coal, still enormous, still elegant, but finished with youth. Not every galaxy ends this way. Some reignite. Others absorb gas from neighbours. Some form bars or rings or strange double cores. The variety is endless, but the trend, on average, is toward cooling. A slow shift from hot, star-bursting youth to cooler, more measured maturity. From chaos to clarity to calm. The universe itself is changing too. Expansion continues and galaxies grow further apart. Collisions become rarer. The sky, once crowded, becomes vast again. The sleepy scientist stirs in their dreams, murmuring under their breath. Their desk is covered with open star charts, aged maps of spiral arms, annotations of quasar locations, sketches of galactic halos curling like faint smoke. Galaxies are more than shapes. They are lives. They form, they flare, they merge, they calm, and slowly they dim. But in their fading light, we find wisdom. Not all brightness needs to burn forever. Some glows remain steady, even in their quietest hour. You drift now toward the outer edges, not of the universe, but of a galaxy. The spiral arms trail off into soft wisps of starlight, then dust, then darkness. Here, at the margin, stars grow sparser. Gas thins into silence. And yet, something strange remains. Motion. Even out here, far from the core, stars orbit with unexpected speed. They should slow down. They don't. This puzzle was once a quiet mystery, noticed gently, like a hairline crack in an old beloved windowpane. Observations didn't match expectations. Stars on the edge of galaxies were moving too quickly, as if pulled by something invisible. This is where we meet the long shadow again. Dark matter. We spoke of it earlier as scaffolding, but now we see its halo, the ghostly sphere that surrounds every galaxy. It cannot be seen, but it exerts influence everywhere. It keeps those outer stars from flying away. We hover at the edge of this dark halo now. There is nothing to see, but there is everything to feel. The galaxy floats inside a cocoon of gravity, unseen but undeniable. The sleepy scientist once wrote a single sentence in a margin of their notebook. What we cannot see, we orbit. We linger with this thought, because dark matter doesn't just keep stars in line, it helps galaxies form, evolve, and survive. The halos extend far beyond the visible stars. They stabilize rotation, they bind galaxies together, and they connect galaxies to the cosmic web that stretches across all creation. Without dark matter, these structures would have unraveled long ago. Even more curiously, galaxies of very different types and histories all seem to have dark matter halos that follow the same rules, as if the invisible hand that shaped them was using the same quiet compass. We float downward now into one such halo, moving from the outer edge toward the visible disk. The stars pass beneath us, scattered like reflections in a pond. Here, we can hear the galaxy breathe, not in sound, but in movement. Orbits, rotations, ripples. There is a rhythm to all of it. We drift past a small satellite galaxy, one of many. Larger galaxies often carry companions like moons around planets. These smaller galaxies orbit slowly, sometimes leaving trails of stars behind them, sometimes merging completely. The outer edges are not empty. They are in transition, and the dark matter halo, though silent, guides it all. You may begin to wonder, what is dark matter really? And the truth is, We don't know. Not yet. We know it has mass. We know it interacts through gravity, but it doesn't absorb, reflect, or emit light. It is not made of atoms. It might be a new particle, or something stranger still. The sleepy scientist has a chalkboard covered in question marks, diagrams of hypothetical particles, elegant lines of unsolved math, and at the centre of it all, here, the dark is not empty, it is full, and it is full of something that holds galaxies together, full of something that built the structure of the universe, full of something we still chase in underground labs and distant telescopes. But in the meantime, we watch its work. Galaxies orbit their centres not because of what they see, but because of what is hidden, like trust, like gravity, like time itself. You linger a little longer at the edge of the galaxy, watching it spin, not frantically, not forcefully, but surely. Stars, dust, dark matter, all moving as one. This is the quiet truth of galactic life. Not everything that matters can be seen, but everything that matters leaves its trace. We turn now toward the smallest galaxies, tiny things, almost imperceptible compared to the grand spirals and giant ellipticals. They shimmer faintly, often overlooked, but they carry secrets in their silence. These are the dwarf galaxies. We drift toward one now. It is faint and irregular, more a gathering of stars than a defined structure. No spiral arms, no bright bulge. It flickers like a lantern barely holding flame in a long hallway of night. And yet, it is ancient. Many dwarf galaxies are among the oldest structures in the universe. Their stars formed early, their patterns frozen in place. Some have barely changed in billions of years. They are time capsules, preserved memories of a younger cosmos. The sleepy scientist once sketched one in a notebook, no bigger than a thumbprint, a loose scatter of dots, with just 2 words written beside it: humble and true. That's what these galaxies are: humble, true. Often found orbiting larger galaxies, they seem like companions or satellites, but their influence runs deeper. In fact, dwarf galaxies may be the building blocks from which larger galaxies formed. In the early universe, small clumps of gas collapsed first, forming these dwarfs. Over time, they merged and grew, becoming the spirals and ellipticals we see today. Even now, larger galaxies consume dwarfs, drawing them in, tearing them apart, absorbing their stars. We pass near one such remnant, a stellar stream stretching like a ribbon across the sky. It's the ghost of a dwarf galaxy long ago devoured, its stars still whispering the path they once followed. In this way, the faintest galaxies leave long echoes. Some dwarf galaxies are rich in dark matter, more so than their larger cousins. They offer clues, quiet ones, about the nature of that unseen scaffolding. Their shapes, their motions, their survival all point to the same strange truth. Dark matter holds them together like thread in handmade lace. Others are peculiar in different ways. Some stopped forming stars billions of years ago. Some have almost no gas at all. Some seem to exist in places where they shouldn't. One, for instance, floats far from any major galaxy, alone, serene, and silent. You pause there now, letting the stillness settle. It doesn't glow brightly, it doesn't spin with grandeur, but it is. And its quiet defiance of expectation is its own kind of light, the sleepy. Scientist once wrote in the margin of a research page, "Even the smallest galaxy has gravity. Even the quietest thing can pull." You begin to see that galaxies are not ranked by size or brilliance. They're each part of a story, each one a voice in the cosmic chorus. And without the dwarfs, Without their early sparks, their dark matter maps, their gentle disruptions, the larger galaxies might never have formed at all. We drift now past a loose collection of dwarfs. They orbit a larger host, trailing behind it like embers from a comet's tail. Some will fall inward, some will remain. All will shape the future of their system, because galaxies are not static. They grow by gathering. The universe itself is collaborative. Nothing truly forms alone. We move on gently, letting the light of the dwarfs fade behind us. They are not gone. They're just behind the veil of brightness. But their gravity, their fingerprints, remain everywhere. And now we begin to understand. Galactic life is not only about the grand or the luminous. It is about presence, lasting, quiet, real. A mirror in the dark. That's what it feels like now. We pass through a patch of space so quiet, so untouched, it almost feels like it's listening. But ahead, suspended in the silence, we see a light not sent but returned. A glint, a reflected gleam, a memory bouncing back. We're approaching the moon, not because we're returning to Earth, but because something was left there. Decades ago, astronauts placed a special mirror on the lunar surface, a retroreflector, a small, precise panel of glass designed to bounce light directly back where it came from. We still use it. Lasers are fired from Earth toward the moon. The beam travels 384,000 kilometers, touches that mirror, and returns. We time its journey down to the tiniest fraction of a second. And in that light, returning across the void, we measure distance, but we also measure truth. Light always travels at the same speed, so every round trip tells us something about where the moon is, about how it moves, about gravity, tides, even Earth's own wobble. But more than that, it proves, quietly, that light is loyal. It returns, always at the same pace, even across silence, even through space. The sleepy scientist has a dusty photo on their desk. Apollo astronauts standing under a low sun, the retroreflector just visible in the soil. Underneath, in neat script, we lit a match, and the moon answered. We linger in this echo of light, from moon to Earth, from Earth to moon, no faster, no slower. Always the same pace, always the same path. Light never breaks the rules, not even by a hair, and because of that, we build things upon it, entire systems, GPS, astronomy, communication. Without that precision, the modern world would be a flicker without focus. But it is not just modernity that rides on the back of photons. Memory does too. We look deeper now, into the light of stars and galaxies, and further still into light that has travelled for billions of years to reach us. Each beam a messenger, each photon a postcard from the past. Even when the source is gone, the light remains. Even when the star has died, its glow continues across space, telling us what once was. That's what telescopes do. They catch the past. We peer now through a great space observatory, its mirror wide as a house, curved and gleaming. It floats in darkness, gathering the faintest whispers of light from galaxies so far away they're barely more than smudges. But they are real. They were real. 13 billion years ago they shone, and now their photons touch our instruments, one by one, like ancient snowflakes. This is not time travel, but it is time's reflection. You begin to see the universe does not forget. Its past is not gone. It's still arriving. A star that blinked in a galaxy long dead. A quasar that flared before Earth was born. A supernova whose ashes are now planets. All of them still speak. The sleepy scientist once wrote in the back of a journal, "We see not what is, but what was, and from it we dream what might be." It's true. Every image of a distant galaxy is a memory. Every dot of starlight is a moment delivered across time, and because of that, we know the universe's story, not in full, but in glimpses, in rays, in echoes. We float now through a wave of photons, some new, some impossibly old. They pass through us like thoughts we've almost forgotten, each one a journey, each one a witness. And as we drift through the river of light, we listen, not just to what shines, but to what shines back. Now let's lie back in the dark and ask a question so quiet, so strange, it almost unravels itself as it forms. What does now mean in the cosmos? You may think you're living in the present, sitting still, watching a galaxy shimmer in the telescope, but that galaxy, no matter how sharp its image, is not now. Its light left millions, maybe billions of years ago, and so you see it not as it is, but as it was. Every star, every supernova, every glimmer of dust you perceive has already happened. The further you look, the older the story. There is no shared present in the universe, no universal now. We float between stars and it becomes clearer. Each point of light we pass, no matter how near, tells a different tale. Not one of them is caught in the moment with us. They're all time travelers, even if they don't know it. You glance to your left. There, a bright blue star burning hot and young. Its light has taken only a few dozen years to reach us. To the right, a faint galaxy, a smudge of ancient photons. Its light has travelled billions of years. They appear beside each other, side by side in the sky. But truly, they are separated by epochs. This is the illusion of now. The sleepy scientist once wrote on a blackboard, before erasing it slowly, deliberately, "The present is stitched, together from different times." We carry that thought deeper now. On Earth, time feels simple, coordinated, predictable. But once you drift into the cosmos, time stretches. It bends. It depends on where you are, how fast you move, how massive nearby objects are. Time is not fixed. It's woven into space like threads in a tapestry. A galaxy 10 billion light years away isn't just distant in space. It's distant in time. That means what we see might be long gone, or transformed beyond recognition, or still continuing in ways we'll never witness. But still, we see it. Still, we learn from it. Because in this vast, ancient universe, the only truth we can fully hold is the light that reaches us. Imagine standing at the edge of a wide field at night. You see lightning in the distance. You don't hear the thunder yet, but you know it's coming. That's how the universe speaks. First in light, then in rumble, if it rumbles at all. And sometimes we only get the light. Sometimes we only get the memory. We drift now to the edge of a massive elliptical galaxy. It's red and quiet, filled with old stars. Nothing new has formed in eons, but it still glows, not brightly, not boastfully, but steadily. Its light is faint, stretched, tired, but it arrives. It reminds us that even fading light is still light, still valid, still true. The sleepy scientist rolls over, wrapped in a blanket scattered with star patterns. On the nightstand beside them is a note written on thin paper, folded in half. It reads, "The sky is not full of stars, it is full of history." And it is. Each point of light is a journal entry from long ago. Each photon carries the story of something that once burned, once exploded, once existed. What we call the present is a mosaic of moments, stitched from across the deep, stitched from all directions. You close your eyes now and you still see stars, but you realize those stars aren't with you. They're behind you, ahead of you, around you, and always, just a little, out of reach. We drift into fog now, a soft mist, not of water or vapour, but of possibility. There are whispers in the physics world, hushed, theoretical, and dreamlike. They speak of particles that never slow down, particles that are always faster than light, particles that may not exist. But what if they did? They call them tachyons. The sleepy scientist once doodled a spiralling path on a napkin, then labelled it not with an equation, but a single word: maybe. Tachyons are the embodiment of maybe. They live on the far side of light speed, beyond the cosmic barrier that nothing with mass can cross. But tachyons are imagined to have never been below that line. They are born faster than light. They remain faster than light, and they cannot slow down without becoming imaginary. If they exist, they would rewrite everything. We hover in this conceptual mist, not to claim tachyons are real, but to marvel at the shapes they leave behind in thought. What would a particle be like if it always moved faster than light? If it always outran the universe's cause and effect chain? The first thing to break would be time, because going faster than light isn't just about speed, it's about causality. It's about flipping the order of things. If tachyons exist, then an effect could happen before its cause. A message could arrive before it was sent. A star could dim before it ever burned. The universe, as we understand it, would unravel like thread pulled too fast from fabric. And yet, we linger here, because there's something comforting about the edge of the unknown. Tachyons may not be real, but their shadow has guided science through complex thought, through questions about what speed truly means, about what time truly is. We float now through a simulation, not a real galaxy, but a mathematical model rendered in soft pulses. In this artificial world, a single tachyon blinks across space, not moving through it, but appearing on either side like a skipped heartbeat. We try to follow it, but we can't. It's always somewhere we can't quite reach, always past the barrier. The scientist once whispered in a lecture long ago, and someone remembered the words, "The speed of light is not just a rule, it's a fence, and fences make shapes. Tachyons, if they exist, lie beyond that fence, not to be caught, but to remind us where the boundaries lie, and what strange things might live outside them, and still we drift further." You think about the fog of early knowledge. There was a time when people didn't know if atoms existed, or black holes, or galaxies beyond our own. Each idea began as a whisper in the mist, each one a maybe. The tachyon is no different. Maybe it's nothing. Maybe it's a signal from the edges of thought. Even if they're never found, tachyons matter. They invite us to think gently but radically, to ask questions that make time wobble and space fold, to remember that science doesn't only grow by answers, it grows by daring to ask beautiful things. We pass now beyond the fog, back into clarity. The tachyons do not follow, or perhaps they're ahead of us, always ahead, always already gone, and in their absence a calm settles, because the mystery remains, and not every mystery needs solving. Some are meant to be wondered at, as we close our eyes beneath the stars and imagine a universe more flexible than our minds can hold. The air around us stretches now, not in a dreamlike way, but in a physical one. Space itself, expanding, not into anything, but of itself. And it's been doing this since the very beginning. We float through a quiet field of galaxies, each one drifting away from the others, not because they're moving through space like ships across water, but because the fabric of space itself is growing, like ink spots on a balloon that's being slowly inflated. And here we find ourselves inside one of the most graceful paradoxes of the cosmos. The universe is expanding, but the speed of light remains untouched. We wonder, if light is the fastest thing, how can galaxies seem to recede from us faster than light itself? This is the secret of the cosmic speed trap. It's not that the galaxies are moving through space faster than light. It's that space itself is stretching between us and them. The light they send must swim upstream through this expansion. Sometimes, that stream grows so swiftly that the light never quite reaches us. It's not breaking the rules, it's following different ones. The sleepy scientist has a ripple pattern drawn in soft graphite. Across it, tiny galaxy dots grow farther apart as the lines curve outward. Underneath, the faster the space grows, the farther the light must go. You pause now, floating in this field of drifting galaxies. Many of these lights will never touch us, not because they weren't sent, but because the universe changed shape beneath them. We realize that the observable universe is not everything. It is only the part that can still reach us, a soft bubble of knowability in an ocean of more. But here's the beauty. Even in this expansion, galaxies don't fall apart. Their own gravity, their own dark matter halos keep them whole. Space grows around them, between them, but inside them, the dance continues. It's like islands rising in a swelling sea. The land does not break. The space between grows deeper, and within that growing space light keeps moving, always 299,792 kilometers per second. No faster, no slower. Even as space stretches, light obeys. Sometimes that obedience costs it everything. We drift past the faint red glow of ancient light. It began as ultraviolet, as X-ray, as brilliant energy. But over billions of years, as the universe expanded, that light stretched, its wavelength pulled like taffy. It became redder, softer, colder. Now it's a whisper, a murmur, barely heat. This is redshift, not just a trick of distance, but of time and space combined. And yet, it still tells us everything. By measuring that shift, we learn how far space is expanding. We learn how far galaxies are. We learn how long it's been since light left home. The sleepy scientist keeps a tiny vial on a shelf. Inside is a curled strip of paper, red ink at one end, violet at the other. It's labelled "The Long Path of a Photon." We admire that path, because even though the cosmos is stretching, the rules hold, the constants remain, and through those rules we see structure. Even in the drift we find meaning. Galaxies drift apart, but they are not lost. Light stretches thin, but it does not vanish. The past moves away, but never fully escapes us. You close your eyes now, floating in the hum of expanding space. The galaxies move away, yes, but they leave a trail of light behind them, and we're always reading it. We close our eyes and fall backward, not into sleep, but into memory. Not ours, but the universe's. Behind every galaxy, behind every star, behind every atom you've ever known, there is light. Ancient, quiet, soft. It's not from a star. It's not from any point you can see. It is everywhere, all around you, even now. This is the cosmic microwave background, the afterglow of creation. We drift toward it now, letting the warm hum of origin surround us. It isn't bright, it isn't loud, it's like static at the edge of hearing, like a whisper inside the walls of everything. It was born 13.8 billion years ago, when the universe was young and hot and dense, a time when light couldn't move freely, caught in a fog of particles too tangled to let anything escape. But then, the fog cleared, the universe cooled, atoms formed, and light, finally, gloriously, broke free. That first release of light is still travelling. It has never stopped, and we can still see it. Not with our eyes, but with instruments tuned to that soft, stretched glow. What once blazed in brilliance now glows gently in microwaves. Cool, constant, cosmic. The sleepy scientist has a tapestry hanging near their couch, a delicate pattern of reds and blues, blotched like clouds or fingerprints. It's not abstract. It's a map of the cosmic microwave background, a portrait of the universe when it was just 380,000 years old. Underneath, stitched in silver thread, we remember the beginning because the light remembers it for us. We drift closer. In this ancient light are tiny fluctuations, temperature differences no greater than a few millionths of a degree. But they matter. Those little ripples, they were the seeds of everything, every galaxy, every star, every planet, formed from the gentle wrinkles in this light. We pass through it now, and it surrounds us like a cradle. The oldest thing we can observe, the most distant past that still reaches us. It speaks without words, but its message is clear. The universe has a history, and light is its handwriting. You begin to understand how galaxies were born, not all at once, not as fixed structures, but as consequences of a dance that began in this faint hum. The light rippled, matter clumped, gravity deepened, and stars ignited. It all began here, and still it continues. The universe expands, the light stretches, the memory fades, but does not disappear. Even now, satellites above us, cold and tireless, record this background. They watch it for shifts, for clues, for imperfections. And in those imperfections they find meaning, shape, clarity. The sleepy scientist keeps an old chart nearby, hand-drawn with trembling lines. It's a graph, showing the brightness of the microwave background. At first glance, it looks like a bell curve, but if you look closer, it's a fingerprint, the universe's own signature, a reminder that everything we know came from a whisper of heat, a ripple of light, and a silence that carried it outward forever. You float now in that silence. The stars haven't yet formed. Galaxies are still dreams, but the light is already on its way, and that's enough. Enough to make all things possible. We drift toward the pull now, not away from light, but towards something it cannot outrun. Gravity, but not just any gravity, the kind that bends light, that curves time, that quiets even photons. We're near a black hole, not to be feared, not to be dramatized, just watched, carefully, softly, like watching a sleeping animal breathe beneath blankets of space. The sleepy scientist once described it this way in the margin of a textbook, where gravity becomes geometry, where motion becomes stillness. A black hole doesn't shine, it doesn't announce itself, but you know it's there by what it does. It bends the path of stars, it warps the routes of light beams, it pulls so steadily that even time itself feels the strain. Around it is a place called the event horizon, a quiet border. Once crossed, nothing, not even light, can return. And so, light, for all its loyalty to speed, pauses here, not in its movement, but in its escape. We drift just outside this border. You look into the disk of matter circling the black hole, gas spirals inward, glowing from compression and heat. But just before it vanishes, it blazes one last time, a halo of fire at the edge of forever. Here, time slows. To an outside observer, things falling into a black hole seem to freeze, not metaphorically, truly. The closer something gets to the event horizon, the slower its time runs, until, at the edge, it seems to stop. From the inside, of course, time continues, but the view changes. The outside universe rushes past, stars blur, light bends around in loops. Because near a black hole, space curves, not just around it, but into it. It's not just a place, it's a direction. And so, light, normally a perfect traveller, finds itself caught, not broken, but trapped in orbit, forever circling. This leads to something stranger still, gravitational lensing. If a black hole drifts between us and a distant galaxy, it bends that galaxy's light around it, like glass bending the shape of a candle flame. The image warps, stretches, duplicates. You're not seeing the galaxy as it is, you're seeing it around the thing that hides the middle, like reading through water. And yet this distortion gives us clarity. By watching how light bends, we learn what must be pulling on it, even when we cannot see the puller. We trace invisible structures by following the curves in light. Galaxies too are shaped by these unseen hands. Supermassive black holes dwell at their centers, guiding the motion of billions of stars like a silent conductor, guiding a symphony without lifting a baton, without a word. And that's what gravity is. A silent shaping, a whisper that stars obey. The sleepy scientist once looked at an image of a gravitational lens and said softly, almost to the room itself, "Light always travels straight." It's just that space isn't straight anymore. You sit with that. Not because it's complicated, but because it's beautiful. Light tries to go in straight lines, but when space curves, the path curves too. The rule still holds. It's just written on a page that's been folded, and now you wonder, not why light bends, but how deeply it trusts the universe, even in the warps, even in the traps. We pull back now, gently, away from the rim of the black hole. The stars regain their clarity. Time breathes again. But what we've seen stays with us. Not just the darkness, not just the distortion, but the faith of light, its loyalty to the path, even when the path ends. We are floating now, slowly, softly, to the very edge, not of space, not even of time, but of what light itself can do. There is a place, just outside a black hole, called the photon sphere, a ghostly shell where light doesn't escape and doesn't fall in. Instead, it orbits, endlessly, caught in the exact balance between gravity and motion. We arrive here in a hush. Imagine a beam of light circling and circling, never spiraling outward, never slipping inward, just turning, always returning to where it started. A perfect loop, a trap of precision. Even for something so fast, this is stillness. The sleepy scientist wrote once in the quiet, "Speed is not the opposite of stillness. Sometimes it's the cause." And here you understand. The faster light goes, the more it must obey the curves of space. And here, space curves so tightly, so steeply, that the fastest thing in the universe becomes a satellite to gravity itself. The light we see from this edge is different, warped, blurred, echoing its own journey. In truth, some of the light you see may have made multiple laps around the black hole before escaping, bent into submission, then finally flung toward your eyes, one last act of freedom. You feel the tension. Light has no mass. It should be immune to pull, but it isn't, because gravity doesn't just act on mass, it acts on space, and light, faithful to its path, travels wherever space allows. And here, space does not allow escape, only balance, only edge. We drift closer still, to the limit of our reach. There is a region, deeper than the photon sphere, where not even circling is possible, where light is born inward, falls inward, dies inward, no paths out, no messages back. This is the event horizon, a name too harsh for something so quiet. It does not burn, it does not warn, it just accepts. Light crosses the horizon and does not return. Not because it's weak, but because the path no longer includes escape. The coordinates of freedom are erased. Inside, time itself warps. It points inward, like the hands of 1,000 clocks frozen at 1 minute to midnight. From the outside, we will never see light reach the centre. We only see it fade, red-shifted into silence, pulled into invisibility. And yet, this edge, the event horizon, teaches us something profound. There are limits, not artificial, not cruel, just true. And light, the most disciplined traveller in the cosmos, follows those limits without question. It never resists. It never asks why. It simply obeys the map drawn by mass, drawn by gravity, drawn by time. You feel your own breath now, slow and steady. You're not falling, you're floating. And somewhere, the sleepy scientist lies curled beneath star maps and hand-sketched equations. One last line remains on the chalkboard, smudged but still visible in the low amber light. Light is not the fastest thing, it's the most faithful. You let those words linger, because they are not just about light. They are about boundaries, about the beauty of obeying paths, even when the destination is silence, about messages that never arrive, and how even those are part of the story. We drift once more around the edge, and then we let go. The stars are quiet now. The galaxies we passed are only memories, soft, luminous fingerprints pressed into the dark. Their spirals unwind behind our eyes, like lullabies remembered from long ago. The sleepy scientist is still. The candle, long gone out, has left only the faintest scent of wax and time, and light, which never rests, has finally led us to a kind of stillness. Not the stillness of stopping, but of understanding. We've drifted through the cosmos together, through birth clouds and ancient radiation, around curves of gravity and the edges of silence, and through it all, light has whispered, not loudly, not urgently, but with rhythm, with patience, with truth. Inhale, exhale. Somewhere in a distant corner of space, a galaxy is just now beginning to form. Its stars have not yet flared, its dust has not yet settled, but it will shine, and that shine will travel across time, across distance, across the cold silence, to arrive somewhere, someday, at a pair of gentle, wondering eyes. Maybe yours, maybe someone else's. But that's the gift of light. It carries stories. Even across billions of years it does not forget. And now, as your body softens into sleep, you carry that story too. Not as facts or figures, but as a calm, a cosmic hush that settles into your chest, into your thoughts, into your breath. Let it drift, let it blur. The galaxies are still spinning, the stars are still sending, and you are part of it all. A soft point of perception in the vast, loving dark.